Hello everyone. In this session we will see Kirchhoff's voltage law. You can call this as KVL. It states that sum of the voltages around a closed circuit is equal to 0. So for this KVL, this is very important point. Circuit should be a closed circuit. We cannot apply KVL to the open circuit. In a short form, you can represent this as summation of voltages, that is sigma V equal to 0. Now, how to apply KVL for any circuit? Here we are going to consider two cases. One is unspecified polarities. For KCL, we no need to think about the polarities because there the importance will be given for the current directions. Since it is a voltage will be associated with the polarities. So we need to consider those polarities while applying this KVL. Suppose we have this network. If the polarities are not specified, then by default, you consider the polarities as positive and negative. Then we need to find the algebraic sum of the voltages around the closed network. That means every branch voltage we need to know. So here source voltage he has given, so we don't have any problem. But here we don't know the voltage. Here also we don't know the voltage. So first we need to find out the voltage across these passive branches also. So for that, again we will take the help of the Ohm's law, that is voltage equal to current into resistance. If you know the current flowing through this circuit, then you can multiply that current with respect to the corresponding resistance value. Then we can get the voltage across that particular element. So we need to find out what is the voltage across the R1 branch, that is V1. Similarly, we need to find the voltage across R2 branch. So in a simple way, my V1 voltage is nothing but current I into the resistance R1, and the voltage across V2 becomes the resistance R3, which is multiplied with current I. Okay, this you can take R2 also, that's not a problem. KVL can be applied in two ways. One is the source voltage will be considered as a positive and the voltage that is appearing across the resistors will be considered as a drop. Drop in the sense it is a negative because you are moving from positive to negative for the passive side, and for the active side the voltage is increasing, that is negative to positive it's going. So often people write the equation as Vs minus V1 minus V2 equal to 0. This is one way of writing. The most simple way to represent the KVL is you just pick the entry polarity. Okay, so however in whichever polarity the current enters, you just pick with that sign, that is plus V1 plus V2 and minus Vs equal to 0. So both the equations will result into the same. So you can see here, if you send this V1 minus V2 that side, you will get Vs equal to V1 plus V2, and similarly if you send this Vs that side, you will get V1 plus V2 equal to Vs, right? So equation remains same. That's your comfort. So the next one is with the specific polarities. So specific polarities in the sense, in the circuit he would have already mentioned, that means minus plus. This may or may not be, like your assumption also may be, or he would have given anything. But if the polarities are specified, we are not supposed to interchange that. Now take the source voltage, resistors and the voltage across each resistor. Now the equation will be, I am going to write in both the ways. The first equation is Vs, that is it is going to minus to plus direction. So it is going from plus to minus, that means it's a drop. So you will have a minus V1, and again it is rising, its potential is minus to plus, so it will be plus V2 equal to 0. Another way is just pick the entry sign, entry polarity, that is it is positive, it's plus V1, and it is the negative, it's minus V2, and Vs is a negative, so minus Vs equal to 0. Now let us solve one numerical on this KVL. Find the current I and voltage across 20 ohm resistor. If you see this network is looking like non-planar network. Non-planar network means we cannot remove this cross coupling of the loop. Okay. This is a planar network, but it is looking like the non-planar network. This network can be redrawn as in this way. You can check here. The 20 ohm and 2 ohm are connected. Here also 20 and 2 ohm connected. And your 8 ohm is connected to the positive sign. So your 8 ohm is connected to positive sign. Only the thing is you need to maintain the circuit originality as it is. So 2 ohm should be connected to negative sign. Here you can see 2 ohm is connected to negative sign and positive is connected to 8 ohm. And 8 ohm this side we did not touch anything. Only this you have brought, these two interchanged. Okay, so once we bring the network to this condition, you can just apply the KVL to this because it is a single loop. You can apply. So since he has not mentioned any polarities for the passive element, you can assume the entry current direction will be a positive and leaving will be the negative. Now let us take the same. Now we need to find out the voltage across the 20 ohm resistor. For that first you need to find out the current. Okay. So any voltage that you need to find out across the resistor, first and foremost we need the current. Because without current, even if you have a resistor, the voltage can be determined only if you know the current value. Okay, to find out this current only we need to apply the KVL. So by applying KVL, so here the voltage across the 8 ohm resistor will be current into resistor. Resistor value we know 8, but current value is the unknown. So you will keep the current as it is. Similarly, you need to find out the voltage across this as a 20I and the voltage across this resistor as a 2 times of I, 2I. Now we know all the voltages. So simply we need to apply the KVL to this. This will be the plus and minus, this will be the plus and minus, this will be the plus and. So now it is 8I plus 40 because I am picking the entry sign just for the easy sake. Then the equation becomes 8I plus 8I plus 40 plus 20I plus 2I minus 100 equal to 0. Okay. Plus 8I plus 40 plus 20I plus 2I minus 100 equal to 0. Now if you simplify, you will get I equal to 2 amperes. And they are asking you to find out the voltage across the 20. So voltage across 20 will become 20 times of the current. So this current we got 2 amperes. So now the voltage across this will be 2 ampere into 20, that is 40 volt. So this is how we need to apply the KVL to any given circuit. I hope it is clear. Thank you.